The purpose of this video is going to be to help you in seeing how decision-making processes are going to be important in creating confidence intervals. One of my experiences is that students have the most difficult time trying to decide, how do I put together a confidence interval? What do I need to know what in the heck I'm doing? So first of all, let's take a look at the different types of confidence intervals. All confidence intervals are created equally at this point in time. We are looking at a confidence interval as being a point estimate for the population parameter. So if we're trying to estimate the mean, then we're using the point estimate x bar, and adding or subtracting the critical value coming from the distribution of the point estimates times the standard error. So that is the same across the board. When we're trying to estimate the population proportion, we're going to use p hat, and the z-score is our critical value because p hats are distributed normally, and then this crazy looking thing is our standard error for p hats. So now what we're going to do is we're going to take a look at some examples that I put together for you in order to help us to make these decisions. So in this decision making process, what I'm looking at is a process of looking at what are we involving, means, proportions, are we looking at one or two samples, because that is some of the information that comes further, is one or two samples, and then finally what's the critical value going to be like, and that's going to be based upon the little flow chart up here. So we may have n being greater than 30, so we're looking at a z value, n less than 30, we're looking at a t. If we're doing proportions, it's always going to be a z. So now looking back to our examples here, let's take a look at our first one. Latasha is a waitress at 7 Heaven Hamburgers. She wants to estimate the average amount each group at a table leaves for a tip. A random sample of 12 groups have a mean of $7.30. Based upon a long-term experience, the standard deviation of the population is $2.92. So is this question estimating the average amount each group leaves as a tip? Is it involving means or proportions? So maybe you should pause the video here and you should go through these questions on your own and you should answer them. So is it means or proportions? Is it one or two samples? Is the critical value or test statistic, because these are all confidence intervals, they're critical values. We'll learn about test statistics later. Is it a T or a Z? So why don't you pause the video, just try to answer those on your own, and then I'll explain it to you. Okay, so for the first one, hopefully you said that this was for means. So what in this is telling me that it's means? Well, if I go over here, I see the average amount. That's my very first context clue that that's what I need to do. It's the average amount. So when I know it's average, I also see that these are numeric values. They're quantitative data, so it's numbers, and they actually have meaning. This is quantitative data, it is ratio data. That's all the context clues I know to know that this is about means. Okay, now the second question, it says, is it one sample or two? Well, I have only one sample to create an interval for, right? She says the estimate, the amount for each table. So there's just one sample here, despite the 12 groups, right? So that's the average part. So this is just one sample. And then the last question that I'm being asked, the last question says, is this a critical value, a T or a Z? Now let's go look over here at the flow chart. So we check the sample size. The sample size, is it greater than or equal to 30? No, it's not. It's less than 30. So what we need to know, because it's less than 30, is we need to know that the critical value is going to, oops, I do need to change this to that one. We know that the critical value there is going to be based upon the T distribution. So this is a T. All right, now let's look at the second problem, and I will ask you on the second problem to do the same thing I ask you to do on this one. What I want you to do is I want you to answer the questions on your own. So a production manager claims that shifts that have a majority of workers on overtime have more defectives than shifts that don't have many workers on overtime. Create a 99% confidence interval to support or refute the manager's claim using the following information. On the morning shift, at least half the workers were on overtime. A random sample of 240 items from the assembly line showed that 24 were defective. Mid-shift has no overtime workers. A random sample of 258 items from the assembly line shows that 11 had defects. Okay, turn it off again and see if you can answer the same three questions as we answered before about this question. All right, hopefully you've taken some time. So let's take a look at the question. Is this about means or proportions? Well, we see defective and 24 out of 245. There's lots of numbers here. And the fact that they were defective or they were not defective, that sets this up to be a binomially distributed random variable. And binomially distributed random variables become proportions. So proportions is what we're looking at here. These are proportions. So I'm not going to write that big long word out. I'm just going to do prop there. Okay, the next one says, is this a 1 or 2 sample? Well, we have 2 samples that we're comparing. We're comparing these morning shift workers to these mid-shift workers. Now, the workers in morning time, at least half of them are overtime. So those are our overtime people. And then the mid-shift, there's no overtime workers. So it's overtime versus non-overtime. That's what we're looking at. We're comparing these, right? Because the production manager claims that the shifts have a majority of workers on overtime, have more defectives than those without any workers on overtime. So one versus the other. This is a 2 sample example. Okay, that rhymes. Okay, so this is 2 sample. Now the next part is to decide, is it going to be a Z or is it going to be a T? And what we see here is that this is a proportion, right? And remember, whenever you have a proportion, it's always a Z. So proportions are always Z-scores. Always, always, always. So Z. All right, now we're going to go on to the third question here, and I want you to do the same thing as we've done before. You try it on your own. So I'll read it. Jordan, a manager of a used bookstore, wants to estimate the average amount a customer spends per visit. A random sample of 80 customers gave a mean of $6.90 and a standard deviation of 245. Okay, try to answer the same 3 questions again on your own. Okay, so the first one is this involving means or proportions? Again, we see the words average amount. That is an indicator that this is means. Furthermore, $6.90 is a quantitative amount. Quantities, ratio in particular, because this is a ratio piece of data, quantitative data, averages tells us that this is about means. So we have means here. Now our second question, is it 1 sample or 2? There's only 1 sample information given, right? A single random sample. So this is 1 sample. And then our last question, it asks us if we're going to have a Z or a T critical value. We're dealing with critical values because we're looking for a estimated average amount spent. So we see that this has 80 customers. Remember that we have our flow chart, n's greater than 30. This is going to be a Z critical value. So our critical value is going to be a Z value in this case. So C is going to be a Z here. And then finally, we have our last question, our question number 4. And for question number 4 here, it says the State Fish and Game Division claims that at least 75% of the fish in Homestead Creek are rainbow trout. Create a 95% confidence interval that can either be used to support or refute this claim using the information that the local fishing club caught 189 fish one weekend and found 125 were rainbow trout. Can the state Fish and Game claim be refuted? So is this involving means or proportions? Is it one or two samples? And is the critical value that we're going to use a T or a Z? Take a few minutes, do this on your own, pause the video, and then come back and check your work. Okay, so first of all, is it means or proportions? Well, a fish is either a rainbow trout or it's not in this case. That's all we're concerned about. And we have 189 fish chosen from, 125 of which were trout. So that is a proportion. That is what we're looking at here, proportions. So these, I'm going to again just write prop because I don't want to write proportions out. And then it says, is it a one sample or a two sample? Well, in this case, there's only one sample, right? We're just looking at one particular time that these local fishing club went out and they caught 189 fish and 125. Plus, there's only one creek that we're looking at. This would be different maybe if there was Homestead Creek and, I don't know, Los Gatos Creek or something. That would be two totally different ones. So we have just one sample here. And then finally, our last topic is what critical value do we use? Well, it's a proportion, right? Remember, proportions are always z-scores. So if we're looking at what the critical value is, we are looking at a z because it is a proportion. So this is going to be a z value. And there you go. That's a little bit about the decision-making process.